All right, we're back. We're going to talk about simplify expressions. You can use algebra tiles to investigate how the distributive property relates to algebraic expressions. So the rectangle at the right has 3 x tiles and 6 1 tiles like this. There, the rectangle is x plus x plus x plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, or 3x plus 6. Now, if you notice the dimensions, it's 3 units high and x plus 2 units wide. So 3 times x plus 2 is equal to 3x plus 6. So rewrite each expression using the distributive property and then simplify. So 7 times 3w minus 5. Well, you just distribute the 7 to each term. So the 7 times w and the 7 times the 5. So it'd be 7 times 3w minus 7 times 5, which gives you 21w minus 35. Now, the 21w and the 35 cannot be added together because they are not what's called like terms. We'll talk about like terms in a minute. 6v squared plus v minus 3 times 4. Distribute the 4 to the 6v squared to the v into the minus 3, like this, using the distributive property. And then I can use the associative and commutative properties to rearrange and regroup and do 6 times 4 is 24v squared. 4 times v is 4v. And 3 times 4 is going to be 12, so it's minus 12. Now, none of these are what we call like terms because they are not the same thing. This one is a constant. This one has the variable v, and this one has the variable v squared. So you can only add or subtract terms that are constants that have the same variable and the same exponent if there's an exponent involved, okay? So here's a couple for you to try. Go ahead and pause the video. All right, we're back. So the first one's going to be 2 times 8 plus 2 times 4n, which gives you 16 plus 8n. All right, b, if I distribute it, it's going to be negative 6 times r plus negative 6 times g minus negative 6 times t. So it's going to be negative 6r minus 6g because you're adding a negative. And then here it's going to be plus 6t because you're subtracting a negative. Okay, 2 negatives make a positive when you're multiplying together. Okay, this one distribute the negative 3, so it's a negative 3 times 2 minus negative 3 times 5q. So it's negative 6 plus 15q. Okay, and the last one with all these negatives, negative 4 times negative 8 minus negative 4 times 3m gives you 32 plus 12m. Again, both of them you're multiplying negatives, so you're going to get positives there. All right? So like terms are terms that contain the same variable with corresponding variables having the same exponent. So like terms have the same variables and same exponents, and then you can combine them. So 5x squared plus 2x minus 4 has 3 distinct terms with no like terms because none of them have the same variable and same exponent. But in 6a squared plus a squared plus 2a, you have 3 terms, but the first 2 are like terms because they have the same variable and exponent. Now, if you add those together, let's say you had 6 apples squared, if that meant something, plus an apple squared. Well, how many do you have? You have 7 apples, okay? So the distributive property and the properties of equality can be used to show that 4k plus 8k equals 12k, and the expression 4k and 8k are like terms. Here's how we do it. 4k plus 8k have a common factor of k. So you can it's like the k was distributed to the 4 and the 8, so you can undistribute it. And then substitute the 4 plus 8 with a 12, and you get 12k. All right. You don't have to go through this step every time if you have like terms. Like I said at the beginning, if you have 4 Klondike bars and 8 Klondike bars, together you have 12 Klondike bars, okay? But if they're not like terms, then you can't undistribute something from them and add them together. All right, an expression is in simplest form when it contains no like terms or parentheses. So let's simplify 17u plus 25u. I'm going to illustrate it using the distributive property. Since there's a factor of u with both of them, I can undistribute it using the distributive property, add the 17 and 25, and get 42u. That's simplest form. So if I have 6t squared plus 3t minus t, I can group the last two terms together because they both have just a t and undistribute the t. Now be careful, if you undistribute a t, you have to have a 1 there as a placeholder. Okay, so 3 minus 1 is 2, so it's 6t squared plus 2t. Again, you can't add the 6t squared and the 2t together. Even though they have the same variable, they do not have the same power. All right, here's a couple for you to do. Simplify them, and if it's not possible, write simplified. All right, we're back. So for 4a, that simplifies to 2n. For 4b, that's actually simplified because none of them are like terms. So for 4c, I would have 4y cubed minus 6y plus 5 because the 2y minus 8y are like terms. So the 2 minus 8 gives me the negative 6. And then 4d, I'm going to have negative 6a squared plus 5a plus 4. So I'd have to rearrange and put the 7a and minus 2a next to each other. And then I'd have to group those together and use the distributive property on those. Get 7a minus 2a is 5a. Okay, and typically when you write your answer, you write the term that has the highest exponent first, and then go from there and write your constant last. Alrighty? Okay, so one more. No, actually, not one more. We're done there. All right. One thing I did want to mention, though, is that in our answer to number 4, when we had negative 6a squared plus 5a plus 4, the number in front of the variable is called the coefficient, C-O-E-F-F-I-C-I-E-N-T. Okay, the coefficient of a term is the numerical factor. It's the number in front of the variable. So negative 6 is the coefficient of negative 6a squared. 5 is the coefficient of 5a. 4 would not be called a coefficient because it's not the numerical factor in front of any variable. Okay? It's just called a constant. Okay? So up to this point, we've talked about the commutative property, the associative property, the identity properties for addition and multiplication, the zero property of multiplication, the distributive property, and the substitution property. So that's it for this section. Please continue on to your assignment. And as always, let me know if you have any questions. Take care.